converting product to sum or the difference. Here we're going to see these four formulas and their proofs with examples. So here, if you observe in these formulas, it's the sum or the difference of two trigonometric ratios and which gives an output in such a way it is a product. It's basically when you add or subtract, you are getting a multiplication in the end of the result. So why this is useful and where it is this useful? This is useful in the methods to find the general solution, right? Because we want to take the common in the factorization method or in quadratic formula method, like anywhere we want the we want to take common. So if we convert these sum or the differences into the product or the multiplication, we can easily take common from those. So let's see all these proofs and do some examples. First one, sine of a plus b plus sine of a minus b, which is nothing but 2 sine a cos b. So we need to take the LHS and get the RHS. So if you observe, this is sine of a plus b. We know we know this formula, right? Sine of a plus b is nothing but sine a cos b plus cos a sine b. Similarly, we know the formula of this also, which is nothing but sine of a minus b. It is sine a cos b. Instead of plus, it comes minus over here. That is cos a sine b. So these are the basic formulas. So just substitute over here, which is sine a cos b plus cos a sine b plus sine a cos b minus cos a sine b. If you observe over here, we can just cancel these two, and the leftover part is nothing but 2 sine a cos b. So this is the required RHS. Second one is sine of a plus b minus sine of a minus b is equal to 2 cos a sine b. So let's just use these two formulas itself and prove this. So LHS we can write it as sine a cos b plus cos a sine b. So this formula, that is nothing but this, I've written it like this, minus write this in terms of this, that is sine a cos b. This minus into here also inside minus is there, it becomes plus cos a sine b. Now these two gets cancelled and you'll get it as 2 cos a sine b. So this is the required RHS. The third one is cos of a plus b plus cos of a minus b is nothing but 2 cos a cos b. So to prove LHS, we need to know the formula of cos a plus b and cos a minus b. So the formula for cos a plus b is nothing but cos a cos b minus sine a and sine b. Similarly, for cos a minus b, it is almost the same, but instead of minus, we'll write it as plus over here, sine a sine b. I think for this formulas, you should remember, for this formulas, the easy way to remember is if inside it is plus, the RHS side you'll get as minus and vice versa. And this And this is applicable only for cos. So let's just substitute the values. You'll get it as cos A, cos B minus sin A, sin B plus cos A, cos B and sin A, sin B. So this sin A, sin B value gets cancelled. The remaining thing is 2 cos A, cos B. So this is the required RHS. The fourth one is cos of A plus B minus cos of A minus B, which is nothing but 2 sin A, sin B. So again use these two formulas and just substitute. So LHS becomes cos A cos B minus sin A sin B. Now here minus is there. So it becomes minus cos A cos B and minus into plus. This is like minus sin A sin B. Actually it should be minus over here. Now just cancel these two values. The remaining thing is minus 2 sin A sin B. So this is the required RHS. Now using all these four formulas, let's solve few examples. In this question we need to prove this. So this whole part is LHS and this is RHS. So we need to take LHS and we need to get the result as RHS. So let's do this. So here you need to assume for the easier calculation, you need to assume this as A and this as B. So if you observe here, it is like cos A and cos B minus sine. This is nothing but A only, right? So pi by 4 minus x is nothing but A. And this is B. So cos A cos B minus sine A sine B. So, so this assumption works. So now we can write it as let pi by 4 minus x is equal to A and pi by 4 minus y is equal to B. Now we can write this LHS as cos A cos B minus sin A sin B. And we know this formula, that is nothing but, now we have just now discussed, that is nothing but cos A plus B can be written as cos A cos B minus y minus minus sin A sin B. And I already discussed the trick, that is plus over here and the minus will come over here. So according to this formula, we can write this as cos of A plus B. So what is A? A is nothing but pi by 4 minus x plus B. B is nothing but pi by 4 minus y. So just add it. Pi by 4 plus pi by 4 is nothing but pi by 2. Take minus common and remaining part is x plus y. So there is a conversion of cos to sine, that is cos of pi by 2 minus theta can be written as sine theta. So if you observe here, it's in the same form, that is cos pi by 2 minus theta. Theta is nothing but x plus y. So this can be written as sine theta. Theta is nothing but x plus y. So this is the required RHS we actually need. In this question, we need to prove this LHS is equal to RHS. If you observe here, assume this is in the form of cos A plus B minus cos A minus B. So let A is 3 by 4 and B is x. So the formula for cos A plus B minus cos A minus B, what it is? It's nothing but minus 2 sine A sine B. So just substitute the values in the formula, in the RHS side, that is this. So it becomes minus 2 sine A. A is nothing but 3 pi by 4. Sine B, B is nothing but x. So this can be written as minus 2 sine 3 pi by 4 is nothing but pi minus pi by 4 sine x. If you see over here, sine is plus in the first and second quadrant and negative in the third and fourth quadrant. So 3 pi by 4 can be written as pi by 4. Pi minus pi by 4 because pi minus pi by 4 comes in the second quadrant. So sine value doesn't change. It remains as it is, that is positive. So we can write 3 pi by 4 as pi minus pi by 4. So sine pi minus theta is nothing but sine theta. So it becomes minus 2 sine pi minus theta. Theta is pi by 4 and sine x. Sine pi by 4 is 1 by root 2 sine x. So this becomes minus root 2 sine x. So this is the required RHS to this question. In this question, we need to prove LHS is equal to RHS. So if you see over here, assume A is equal to 3 pi by 2, which is nothing but this, and B is equal to x, because the LHS part is in the form of sine of A plus B plus sine of A minus B. Because the LHS is in the form of sine of A plus B plus sine of A minus B. So we have just seen the formula, that is sine of A plus B plus sine of A minus B is nothing but 2 sine A cos B. So according to this formula, we can write it as 2 sine A is nothing but 3 pi by 2 and cos B. B is nothing but x. So this 3 pi by 2 can be written as sine is plus over here, plus, negative and negative. 3 pi by 2 is nothing but pi plus pi by 2 cos x. So pi plus pi by 2 is pi plus pi by 2, which comes in the third quadrant. So it becomes minus 2 sine pi by 2 cos x. Sine pi by 2 is nothing but 1. So it just gives minus 2 cos x. So this is the required RHS to this question. In this question, we need to prove LHS is equal to RHS. And if you observe, in LHS side, assume A is equal to pi by 3 and B is equal to y. Why? Because it is in the form of sine A plus B minus sine A minus B. So the formula is sine of A plus B minus sine of A minus B is nothing but 2 cos A. First comes the cos, next sine B. So just use this formula and substitute the values. So it becomes 2 cos A is pi by 3, sine B is nothing but y. So cos pi by 3, cos 60 is nothing but half sine y. So the required answer is sine y. In this way, we'll get the required RHS to this question. In this question, we need to prove LHS is equal to RHS. So here we need to assume A as 5 by 6 and B as y. because it's in the form of cos A plus B plus cos A minus B. So according to the formula, cos A plus B plus cos A minus B is nothing but 2 cos A and cos B. So just substitute the values in this formula. You will get it as 2 cos A is nothing but 5 pi by 6. Cos B is nothing but y. So this 5 pi by 6 can be written as pi minus pi by 6 cos y. So if you see here, cos is positive in first quadrant and fourth quadrant, negative in these two quadrants. So pi minus pi by 6 comes in the second quadrant. So it becomes negative. So minus 2 cos pi by 6 cos y. So cos pi by 6 is nothing but root 3 by 2 cos y. So this gets cancelled. Minus root 3 cos y. So this is the required RHS to this question.